Good morning, students. Today we learn about our steam properties. This is our first lecture. In this lecture, we cover what is steam and how we can generate steam with the help of boilers or steam generators. Let's start. First of all, what is steam? Generally, we know that the steam is the gaseous phase of water. As we know, the water can exist in three phases. First is solid, that is the ice, then liquid, that we know as the water, then it is the gaseous phase, that is steam. We generally convert a solid phase of water into a gaseous phase with providing adequate amount of heat energy to the solid phase. Now, why we need to generate a steam? The steam is the most important source of energy which we can use in any thermodynamic system as a working medium, just like same to a IC engines. For example, in internal combustion engine, we burn a fuel which produce a amount of heat energy which we can convert as a mechanical work with the help of various setup. Similarly, in steam engines and steam turbine, we use steam rather than a fuel. This steam acts as a source of energy which produce a mechanic in any thermodynamic system. Now, steam have certain properties which make this possible to use as it a working medium. Let's start with the properties. Now, first of all, it contains a large amount of heat energy. Second, water is the cheapest source and it can easily available at any destination. So we can easily collect the water and convert that water into steam. The next point, even after using a steam in a steam turbine or steam engine, there is some heat energy which present in the steam. We can use that energy in different source for different purpose. For example, to wash any equipment with the hot water, or even if we use this steam energy in a proper steam power plant, we need to condense the steam with the help of condenser. Now, another benefit of steam, we can use it for the cooking purpose because it is the most hygienic way to cook any food. So it is also beneficial using in a food industry. Now, how we can form a steam, how we can generate a steam? In general way, we can convert a water into steam even at our home. For example, in our cooker, when we add some water in a cooker and start providing some heat to that, the water starts converting into a steam. How to produce in a industrial purpose or for producing some work, we need to produce in a large vessel, in that are closed vessels. Those vessels are known as a boiler or steam generator. In market, there are two type of boilers are present. First is the water tube boiler. Second is the fire tube boiler. The water tube boilers are in which the water is moving through a pipeline and there is a flue gases outside that pipeline, and it absorbs the heat from the flue gases and convert into a steam. In a fire tube boiler, we generally passes the flue gases through the pipeline and the water is flowing around that and it absorbs the heat from the pipe and converted into a steam. The efficiency of water tube boiler is more as compared to the fire tube boiler. We cover this topic, water tube boiler and fire tube boiler, in another lecture. Now in this lecture we stay tuned with the formation of steam. Now to generate a steam, we study one curve for steam formation. Okay, this is the steam formation curve. It is showing to conversion of steam from minus 10 degrees Celsius to a superheated state. We cover this in the different stages. Let's start with this point where my cursor is pointing. Over here we having a ice whose temperature is minus 10 degrees Celsius. Now we start adding some heat to this ice. In the starting, when we add some heat, it starts and it moves along this curved line and reaches the point 0. And here it is showing that this path is denoting with the point that is A. This A is known as the sensible heat taken by ice. This means the ice absorbs some heat energy and its temperature increases from minus 10 degrees Celsius to 0 degrees Celsius. This does not mean that the ice melt into a liquid phase. Even over here, over this point, it is in a solid phase. Then further, if we add more heat energy, it starts moving from here 0 degrees Celsius to along this line. Along this line, it starts absorbing a heat energy and starts changing its phase from solid state to a liquid state. This B, this is known as a latent heat of fusion. We generally use two words for heat absorption. One is a sensible heat, another is a latent heat. The sensible heat is absorbing when there is a change in temperature. For example, from this point to this point, there is showing some temperature difference from minus 10 degrees Celsius to 0 degrees Celsius. However, over here, there is no change in temperature. If you notice that, we know the point in which we absorb some heat energy, and that concept is known as an isothermal process. We generally say the isothermal process is not a feasible process, but it is possible to use this process in the state where we having two phases. For example, when we having a chances to transform a phase from solid to liquid or from liquid to gases. Therefore, it is possible in the case of steam. Okay, now let's move further. The point which is pointing from here, from this point to this point, then we add heat further to the liquid phase. It starts boiling and it reaches over here. This phase is denoted with C. It is known as a sensible heat of water. Sensible heat, that means the heat which is taken via water to increase its temperature from 0 degrees Celsius to 100 degrees Celsius. From 0 degrees Celsius to 100 degrees Celsius. This HF, it is known as the enthalpy of water. The enthalpy means the amount of energy which is absorbed by water to convert to change its temperature from 0 degrees Celsius to 100 degrees Celsius. Now, when it reaches at this point HF, when we further add heat to this, it is a straight line which is denoted with D. This is known as the latent heat of evaporation. This means the liquid phase of water is transforming at a same temperature from liquid to the gaseous phase. Over here, HF point, we having 100 degrees Celsius water. When we reaches this point Hg, over here we having 100 degrees Celsius dry steam. In between this HF, we having a steam, but that steam is the wet steam. We generally not use a wet steam in steam engines or steam turbines, because if the steam having some moisture, it produces rust over inside the system. To understand this HF, we need to study one term, that is the dryness fraction, that we cover in the coming lecture. Then from Hg, if we further add a heat to the steam, then it is absorbs heat and it reaches this point, that is the superheated state. This is known as the specific enthalpy of heater steam. These are the various terminology which is relating to the formation of any curve, steam formation curve. A point is representing a sensible heat, B is the latent heat of fusion, C is the again sensible heat, D is the latent heat of evaporation, E is the sensible heat taken by the steam. This is the various enthalpies. H means specific enthalpy. We know that the capital H is known as the enthalpy. When we divided the capital H per unit mass, then it is become a specific term, that is the specific enthalpy. These are the specific enthalpies, that is HW means the specific enthalpy for water, HF means the specific enthalpy for saturated water. Saturation term generally used for a 100-degree curve, the saturation curve, which is divided into two parts. One side is known as the saturation liquid curve and another is known as the saturation steam curve. Then it is the latent heat of evaporation, then it is enthalpy of latent heat of evaporation. Then Hg is the specific enthalpy of dry saturated steam. SUP is the specific enthalpy of superheated steam. Okay, now this whole curve is basically for a constant pressure. Now then we have a chances that there is a variation in the pressure line, so we can generate this curve for different pressure. I show you. This is the curve which is representing 3 points. One is P, P1 and P2, and the formation of all these three curves is same. Okay, the formation of this curve is same. Starts from 0. For P, it moves along from A to B, then moves along this line, and over here it is the dry steam, then it is a superheated steam. Then again for different pressure it moves from A to B1, then to C1 and again to D1. The variation is same in all cases. In this case we having a sensible heat of water, over here it is a latent heat of evaporation, then it is a we add some heat and that is the enthalpy transformation towards the superheated state, and in between this we having both phases. This inside this round curve we having liquid as well as vapor phase, and then towards the left side where my pointer is pointing out, over here it is a water region, means totally we having a water phase over here, and towards this we having a superheated region, that means we having a dry steam over here. That's all for today. I hope you enjoy this lecture, and I will in the next lecture I will cover these topics, various definitions relating to a steam and steam table, how we can use steam table, Molière chart, and we also solve some numericals. Hope you enjoy this. Stay tuned. Thank you.